Hi everyone, today we're going to do a short lesson on scatterplots and lines of best fit. This kind of question comes up on every single SAT test that I've seen so far, so you better get used to it. The main thing, and I guess the only thing you need to understand, is that a scatterplot is just when you have a bunch of data points and you can imagine how it's like scattered all over the place. For example, you might have something like, your X value being hours of SAT study and your Y values being like your score or something, giving a very lame example. So then you might have all these points collecting data from somewhere, and your scatter plot might look somewhat like this. So what you need to understand is that there is a general trend here. As you can probably see, I could draw a line of best fit. This is pretty self-explanatory. A line of best fit is a line that best fits the data that you have, quite literally. So if you look at this very rough and ugly data that I have presented, you can see that there is a general upwards trend, and you could draw a straight line roughly like this, and that would be your line of best fit because it is like the best fit for the data you have. But you will have outliers like here or here, for example, where it's not quite on the line and it's far away, and that's expected because whenever you're collecting data, you can't expect nature to be perfectly in line with your line of best fit. But as long as you see some sort of a correlation here, like you notice this upwards trend, then that shows something. Well, you'll never be asked to actually draw a line of best fit, but oftentimes you will be asked to calculate it, and when you do that, it's the same thing as any other linear line. So anything else, so line of best fit can come in different forms, as in the SAT, you only have to do the linear version, but you might have this kind of line of best fit. You might have all sorts of options, right? And you won't be shown this in the SAT, so don't worry about that. And the other kind of question that you might be shown in the SAT is probably more like asking you to interpret what it means. If that's the case, I can't really explain that to you. It's more of a case-by-case basis. You have to understand what the X value stands for. In this case, it's hours of study. You have to understand what the Y value stands for, is the score. Then you have to interpret it. So that depends on the question. Now, let's just look at the first type of question that comes up, which is, let's read it. The scatter plot above shows the average production costs, its cents per pound of coffee in Ecuador for years from 2002 to 2012. Whenever I'm reading a question, I kind of like to underline the units and the main parts that they're talking about, and not the background information. In this first sentence, I'm just going to pay attention to this. I'm not sure if that's relevant yet, but just in case. A line of best fit is also drawn. See, they always have a line of best fit drawn for you here. Which of the following is closest to the difference in cents per pound between the actual average production cost in 2012 and the average production cost in 2012 predicted by the given line of best fit? So what are they asking you for? They're asking you for a difference, right? And that difference is between the actual average production cost in 2012. So let's go on the graph and let's look at what that is. In 2012, so it's 2010, 11, 12, the corresponding data point, the actual data point is this value. So that is 90, okay? So that's 90 cents. This is the actual data point for 2012. And then the average production cost in 2012 predicted by the given line of best fit. Here's the word that I want you to pay attention to. They will often use the word predicted because, once again, the line of best fit is not exact. It can't be accurate. Rather, it's kind of giving you a prediction, a rough estimate So this is a word that you will see quite often and you should be familiar with. You want to make sure that you never see the word like exact when in an answer choice in a different kind of question, and you'll want to look for words like predicted because it kind of gives you a rough estimate. Anyways, going back to the question, it says average production cost in 2012 predicted by the given line of best fit. So we go up and we look at the point that corresponds to the line of best fit here. I'm going to erase it so we can see it better. It looks like it's roughly like right there between 75 and 30. Can you see like this little point right here? It's between, let me zoom in. You can kind of tell it's between, oh goodness, no, it's not at all. This is why you want to be more accurate. If you had to draw like an imaginary line, which I prefer to do, it would be roughly there. I'm just going to say 80. They won't ask you to be too accurate. So I'm going to say roughly 80 cents is the prediction. Now they want you to find the difference. So 90 minus 80 is 10. 10 cents is the difference between the actual data point and the predicted data point. And the closest number to 10 here is 8, which makes sense because, once again, zooming in, this is just a little bit above 80, so that probably is around like 82, right? So the answer choice is B. Okay, let's do another question to get familiar with this. This is another one. The scatter plot above represents the salary Y in thousands of dollars and the number of years of experience X for each of 6 employees at the company. A line of best fit for the data is also shown. Which of the following could be an equation for the line of best fit? Okay, so this is just like any other question when they give you a line and they're asking you to find an equation. So this should be pretty straightforward. I'm going to pick 2 points that look pretty obvious to me. One that sticks out is, 5 right here. It's like straight on the line. So straight on this like grid line they're giving us. Between 53 and 57, I'm just going to write everything out. 4, and since there's like an in between here, that means it's 4 divided by 2, which is 2. This means that this is 55, right? So the first point I'm just going to choose is 5, 55. Second point I'm going to choose, I'll probably choose this one just because it's pretty simple as well, and it's 1, 49. Now, knowing that this is a linear line, it's a straight line, then I know I'm going to have to use this y equals to mx plus b formula. Let's start by looking for the slope. The slope formula is y2 minus y1 over x2 minus x1. So plugging that in, you get y2, 55, minus y1, 49, over x2, 5, minus x1, negative 1. So you get 6 over 4. Roughly 3 over 2, or roughly 1.5. That is going to be your slope. For the b value, that is the y-intercept, right? The y-intercept is the point where x is equal to 0, or basically where it touches the y-axis. So let's look here. We have to make a rough estimate of where it touches the y-axis. So let's see. You have 2 options here. The first option is you can go through and solve it by, oh, my bad. You can go through and actually solve what it is by plugging this into here, picking a point, either this or that point, plugging that and, that and that here, and then finding the b, if you understand what I mean. But the easier thing to do is they already provided you the line until this point, so you should be able to tell kind of like a rough estimate what this is. If I had to guess, it's between 45 and 49. This is 47, this point, a little bit above 47, so we could just say like roughly 48. Okay, looking at the answer choices, let's eliminate the answer choices. 95 over 2, let's figure out what that is. 95 over 2 is 2 times 4, 8, 1, 15, 2 times 7, 14, 1. So roughly like 47 point some number, which makes sense with our rough estimate as well. Okay, so that means the correct answer has to be 3 over 2 x plus 95 over 2. Does that make sense? Okay. Well, good luck taking the test and bye.